Hey everybody, I want to talk to you about acids and bases and strong versus weak. Now first of all, when we hear the phrase strong, we hear the phrase weak, we might be tempted to think that a strong acid is an acid that burns you and a weak acid is an acid that won't burn you, and that's not true. Same thing with a strong base can burn you and a weak base can burn you. And oftentimes that's because of concentration. If you take hydrochloric acid is a strong acid. And here in a second, I'll tell you what that means. But if you water hydrochloric down so that it is, say, 0.01 molar, in other words, only about 1/1000th of a mole per liter of solution, well, that's not going to be very dangerous. It's not going to burn you, but it's still considered a strong acid because it's not about the concentration. It's about the ionization. Okay, so what does that mean? Remember that acids are proton donors in solution. Okay, that's the Bronsted-Lowry definition of an acid. And so what happens is a strong acid is an acid that when it goes into solution, it gives every one of its molecules give up a proton. In other words, if it's hydrochloric acid, and you've got 100 hydrochloric acid molecules in a drop of water, all 100 of those molecules will give up a proton. Each and every one. That's the definition of strong. Now, if you have 100 molecules of hydrochloric acid and you put it into a swimming pool, you're still going to have 100, or every single one of those hydrochloric acid molecules give up their proton, which is why hydrochloric acid is still a strong acid, even when it's very dilute. Obviously, 100 molecules, that is such a small amount that in a swimming pool you wouldn't even notice. There's probably that much in there already. You just wouldn't notice it, and you wouldn't be afraid to swim in this because it's so diluted. But hydrochloric acid is considered a strong acid. And in fact, there are 7 strong acids: hydrochloric acid, hydrobromic acid, hydroiodic acid. Those 3 acids that are made from the halogens, the 17th column of the periodic table. However, hydrofluoric acid is not considered a strong acid. Even though hydrofluoric acid will etch glass, it is not considered a strong acid because it doesn't completely ionize. If you put 1,000,000 hydrofluoric acid molecules into a liter, better be a plastic beaker, maybe 10% of them will actually give up that proton. The rest of them hold on to that proton just a little too tight to be considered a strong acid. But hydrochloric acid, hydrofluoric acid, hydroiodic acid are all 3 strong acids. The other 4 strong acids are oxyacids. They're made from polyatomic ions. Sulfuric acid, chloric acid, perchloric acid, and nitric acid. All 4 of those are considered strong acids because, again, they all give up that proton. All right. All other acids are considered weak acids. Now, that doesn't mean you want to go stick your hand in a bottle of what we call glacial acetic acid. Glacial acetic acid is basically vinegar. Vinegar is a extremely dilute form of acetic acid. You wouldn't want to stick your finger in there because it would burn the crap out of it. It would hurt. All right. And in fact, historically, there was a general named Hannibal Barca who actually used acetic acid to burn his way through some mountains to make room for his army to march through over some mountain passes, and there were some rocks in the way. So it's pretty powerful, but it's still considered a weak acid because it doesn't completely ionize. All right. On the base side of things, it's the exact opposite. In the case of a strong base is a base that will accept where you have all these molecules, and every one of those molecules will accept a proton. Whereas a weak base is one where only a portion of those proton-loving bases will actually accept a proton. Example of a strong base is sodium hydroxide. Sodium hydroxide is the main ingredient in oven cleaner. And certainly you wouldn't want to get it in your eyes. It burned. I cleaned my oven while we've been on stay-at-home orders, and it'll burn your hands if you don't wear gloves. Some pretty powerful stuff there. But again, like strong acids, if it's diluted enough, it's not as dangerous. But nevertheless, a strong base is something that completely, where every one of these molecules except a proton. And again, it's a pretty short list of what is considered a strong base. If you go look at those alkali metals, all right, which is where we're going to look, we're going to find every one of those alkali metals form strong bases. So lithium hydroxide, sodium hydroxide, potassium hydroxide, strontium hydroxide, those all form strong bases. The other strong bases are calcium hydroxide, magnesium hydroxide, strontium hydroxide. So again, alkaline earth metals. And so those first two columns, and that's because they're just hungry for that extra proton, and they readily accept those protons when they're put into solution. All other bases, including, for example, ammonia, of course we know ammonia will burn you. Sodium hypochlorite, also known as bleach, you wouldn't want to get that in your eyes. It'll burn you very badly. It's very dangerous to splash into your eyes. Those are still considered weak bases because they do not have 100% of those molecules accepting protons. Now, how can we tell? Well, there's a couple ways you can tell the difference between strong proton or strong acids, strong bases, weak acids, weak bases. All right, first of all, is you can just memorize the list, which is what I've done, and because, hey, it's a list of 7. How hard does that be? All right. The other thing you can do is you can look at something called a pH scale. Now, the pH scale is just a way of measuring the strength of an acid. And, for example, our stomach acid is mostly hydrochloric acid. It has a pH of 2. All right, if we take that out and we take 1 drop of hydrochloric acid, the stomach acid, and we put it into a bathtub, and we take the pH, it's still 2. Okay, so that's that strong acid part of it. Anyway, okay, so what is that? Well, the pH scale is a logarithmic scale. It's actually the negative logarithm of the molarity of hydrogen ions in the solution. What does that mean? All right, for us, what it means is that every step on the pH scale is 10 times stronger or weaker than its neighbor. So, for example, that stomach acid, that's a pH of 2, is 10 times stronger than an acid that has a pH of 3, or 100 times stronger than an acid that has a pH of 4, 1,000 times stronger than a pH of 5. For example, orange juice, lemon juice has a pH of about 5, and it's 10 times stronger than, say, Coca-Cola, which has a pH of about 6. If a solution has a pH below 7, it is considered an acid. And if it has a pH above 7, it is considered a base. And again, every step is 10 times the step before it. So oven cleaner has a pH of 14, so that is 10 times more basic than, say, bleach, which has a pH of about 13. So every one of those steps, so you can take small steps and have big differences in the strength of your acid and strength of your base. All right, I've included in the notes that I sent out and attached to the website a chart that has the pH of some common things you might have around your house: coffee, lemon juice, soda, battery acid if you happen to have a car, stomach acid if you happen to have a stomach. I know, we all do. But those sorts of things. So I encourage you to print that out, and when we do have access to our notebooks again, to glue that into your notebook. When we get back to class, and I hope that we will at some point, I'll try to give us a day where we can actually take and cut out all these graphics that I send you. Another thing that I've sent you is a list on the lessons for this week. I've also sent you a graphic on a list of strong acids and strong bases. And remember, if it's not on that list as a strong acid, it is in fact a weak acid. If it's not on the list as a strong base, it is in fact a weak base. Finally, what I want you to do is I've included a reading science with this week's work on the strength of acids and bases, which is about our pH scale. And so read that, answer those questions, and then submit that back to me through email. And so again, the best way to do this is to print it out, complete it, snap a picture of it, send me that picture to my email at rpresley@mesaisd.net, or you can attach it as a picture and send it through the Remind app as well. And so anyway, that's all I have for now. I'd like to set up sometime where maybe we can ask questions. Again, if you have any questions, don't hesitate to email me, or if you post questions in the comments for this video, I'll answer them, because chances are if you have a question about it, there's someone else in the class that has a question about it too. And so they may appreciate your being the one that's brave enough to ask the question. So until then, stay safe, stay well.